Hello friends, this is Prashant Mishra. Today we will talk about CNAPP or Cloud Native Application Protection Platform. This is a term I've been hearing a lot from people that I interact with. I'm working on one of the technologies. A lot of people in cybersecurity, they are confused about what CNAPP is. There are various terms floating around like CWPP, CSPM, CIEM, etc. So I thought I'll do a detailed video on what CNAPP is. So CNAPP essentially is a set of technology, or it's a security platform that's designed to protect cloud native applications. And these applications are designed and deployed using cloud computing technologies that have been growing in last few years. Uh, and essentially it includes things like Docker, Kubernetes, and cloud-based environments. So that's the high-level definition of CNAPP. But to understand how CNAPP works, you have to understand how cloud-native applications work. So let's understand the building blocks that are there in a cloud-native application. So there are four key building blocks. One is the microservices architecture. So this essentially breaks down an application into smaller, more modular services. Containerization, which is all about packaging these services into lightweight portable containers that can be easily moved between various computing platforms. So you can create a container and move it between an AWS or an Azure or a private cloud based platform. Then the third block is DevOps, which is essentially a methodology that brings together development and operations team together to keep that application running in a most effective way. It also includes continuous delivery, which allows organization to deliver applications more quickly and reliably. It includes automation. As you know, automation is very important today. It helps you to streamline development and deployment process. Now these are the components of a cloud native application. Let's look at the application components also in that regard. So a modern application typically would have three categories of blocks, which is software artifacts, workloads, and infrastructure. So let's take a software artifact first. So software artifact is actually, it includes application code. So like in your streaming application, take Hotstar, and I'm not associated with any of the technologies that I'm going to mention or any platforms. I'm just using these as an examples to learn. So Hotstar app that you're downloading on your mobile phone or on your streaming devices, that's an app. It has a code written by the developers. Then these code will refer to some of the open source components. So based on the platform, so it could be Apache, Node.js, Lib4j, Python, etc. Okay, and depending on what the components are, so whether it's the front end, back end, and which platform you're doing the development on. Okay, then there's APIs. So APIs help third-party products to take data from this particular app. Example: today smart TVs can automatically pull the catalog of new shows and movies that are coming in Hotstar and display it as in your smart TV. IC scripts. So this helps you define resource pool set and then automate the deployment of this resource pools. Images, these are set of archive files needed to run containers and its processes, and essentially it's a template. Repositories, this is a collection of related container images that provide different versions of the application. Okay. Registry, so a registry is a collection of repositories that store container images. Okay, they also store API paths, they also store access control rules. So typically the artifacts are stored on repositories, and all repositories are stored in a central registry typically. Okay, so I am not giving you details on how complex the applications are architected, but this is a generic understanding, right? So that was all software artifacts. Workloads, so these are essentially containers, serverless functions, as well as the virtual machines. Okay, uh, please watch tons of videos or other content that's available on internet to learn more about this. It's very important that you understand these jargons to build an understanding of how a CNAPP works. Okay, now that was the building blocks of cloud native applications. Okay, let's look into the DevOps. So there are two more parts that we have to understand in detail. So DevOps, going back to DevOps, which is an approach that combines software and IT operations to help organization deliver software applications in a effective manner. Okay. Now, if you're watching this content on YouTube, I'm showing a lot of images. If you're listening on my podcast, that's fine too. But essentially, dev and ops are two terms, which is bringing development, and operations, which is when the application is running and putting them in a connected way. Okay. So dev is all about building, testing, coding, and planning the application development. Ops is about releasing, deploying the app, running the app, measuring, using telemetry. Okay. So DevOps process has this entire process is connected today, and also there's a concept of pipeline in that. But essentially, it involves multiple software and technologies to automate this entire development and operations lifecycle. And all these components are connected. There's a lot of automation used, making it easy for application developers and the application owners to monitor the applications. Okay. It includes CI/CD, it includes source code, version control software, configuration management, etc. Okay. Now, as you can imagine, there are various technologies available depending on your application requirements. So there are various tools available for for coding, building, testing, deployment, operations, monitoring, etc. Right. And I highly recommend going through a DoD document on DevSecOps, which is all about introducing security into the DevOps process. Okay. So because there are various tools available, today's DevOps process is it's complicated, and also it increases our efficiency. And that's why you might have seen a lot of job opportunities coming in the DevOps line in the last few years. Okay. Now, in CI/CD, it's what happens is this CI stands for continuous integration and continuous delivery, uh, and also continuous deployment, which is another stage. Which essentially it's all about introducing efficiency into the development and testing and the deployment process, right? So while the developers are writing code and committing that code into the uh, version control systems, the testing is automated, and builds are automatically created. In case there are issues, the builds are failed, and if builds pass, uh, it moves into the deployment pipeline, and essentially it goes into either a staging or a production, right, based on the outcomes of the previous process. So because everything is linked, it's called a pipeline. Again, there are various tools available for CI and CD process. So example, in CI there is GitHub, GitLab available. In building an automation side, there is Jenkins, GitLab, Docker, Maven, Selenium, etc. These are very common tools that I've mentioned. For release automation, so JFrog is very common, Nexus is common, Docker is of course common. And then for deploying the application in the infrastructure, Azure, AWS, GCP, as public clouds as well as private clouds or virtual platforms are very common. Okay. So as you would have been realizing, cloud native applications have eased the process of building applications, testing applications, and deploying that applications, right? So the entire DevOps or this entire CNAPP world has essentially native infrastructure provided by the underlying private or public cloud. It has orchestration technologies, container, CI/CD pipeline, and of course the application itself. Okay. So what happens is, if I have to summarize, developers write code. That code goes into a repository. From there, because of a trigger that's configured, there is a pipeline that's executed for testing the lab. If it is the test is successful in this process, the images are pushed to a registry, and there is another testing that's done. And if that also is passed, the software gets deployed in the environment. Okay. That's CI/CD for you. Now, there is an amazing documentation available from CNCF, Cloud Native Foundation, and essentially it talks about what technologies are provided by various companies today. So I highly recommend going to searching for CNCF landscape. You will learn a lot from the document. Okay. Now, going back to CNAP. Okay, remember we started with our objective is to understand what CNAP is. So going back to CNAP, so the purpose of CNAP is to provide security for cloud native applications across all the phases of development, right? So during the DevOps process, the cloud native application protection provides the security. So it essentially includes artifact scanning. So we spoke about artifacts like code, IC templates, registries, container repositories, uh, etc. The configuration of the cloud infrastructure, as well as while the application is in operations phase, the runtime protection. So a CNAP provides the security and around the DevOps cycle. Okay. So how does it do that? So what it does, the CNAPP technology is typically comes as either as a SaaS service or as a on-premise software that you can deploy close to wherever your applications are getting developed, or if you can connect your applications to cloud, that's fine too. Okay. So what it does is it integrates and it collects data. Now, data can be collected in two ways. One is passive collection, also called as scanning mode, uh, also called as agentless. So there is no agent required. So what it does is it looks into your uh, various tools, technologies used in the DevOps process. So example, it would collect data from your underlying cloud platform, and things like resources, virtual machines, serverless infrastructure, whatever is provided as part of that infrastructure, that data is pulled. It also integrates with tools in your development process, like your IDs in certain cases. It also integrates with your registries and repositories. It understands how source code is talking to other codes in terms of the OSS components. It integrates and with repositories and looks at the IC code. Okay. So typically in the agentless or passive mode, it is reading information and analyzing it. In the agent-based mode, also called as active or inline mode, it looks at the traffic that's coming to the application during the operation phase, and it understands the traffic, intercepts it, and blocks it if it finds anything that's malicious. Okay. uh, as you can imagine, agentless is a typical way of where customers or end users of CNAPP platform start, because it's not intrusive in nature. It helps them assess the current state of their infrastructure. Okay. Now, what happens in the data analytics phase is once the data is collected, the platform builds baselines, it finds outliers, it keeps reading data from various integrations that you have provided, it compares that data with threat intelligence sources, it gives you a query platform uh, to look for specific things. Now, it also comes with a policy engine. So in case you have a policy that has a match, then it gets an alert. These policies are typically for either for security use cases, configuration use cases, identity specific use cases, or for state change use cases. Okay. It also prioritizes based on the risk, uh, and it does it across multiple cloud platforms. So that's the advantage of CNAPP. Now, in certain cases, it might give you remediation options in case there are options available. The best part about CNAPP is that it is cloud agnostic. So you can use a single CNAPP platform to take data from environments across private cloud, public cloud, or within various clouds. So, example, I've seen deployments or customers, they have application that one set of applications getting developed in AWS, uh, which is a public cloud, other set of applications getting developed in GCP, other set of application getting developed in VMware Tanzu like infrastructure, right? And they want to have a single platform that gives them complete visibility of the security issues in the entire DevOps cycle across multiple applications. So imagine large companies who have hundreds of applications. Some of the largest companies in the world have thousands of applications. Okay. for various uses. Now that's the good part because it works across multiple cloud infrastructure providers. Okay, now let's take an example. This uh, on in AWS, typically when if a, d- if a developers have set up their entire DevOps process on AWS, they would be writing code in their ID like Visual Code Studio. They would be committing that code in the code pipeline, code commit, and typically there are open source tools that are commonly used uh, across various stages of this entire DevOps process. Okay, uh, these tools are again taking data from S3 buckets. They're looking at CloudWatch events. They're looking at CloudTrail events. Doing dynamic code testing. They're looking at static code testing, software configuration analysis. Okay, and it's very common. They also take data from security hub application vulnerabilities and also from Lambda in case you're doing serverless functions. So it depends on what your application is touching, whatever your DevOps process it's touching. Various open source tool will take down from their data, and developers use these individual tools to find issues. Okay, and it becomes complicated because of the number of applications that they might have, number of environments that they have. Okay, and hence it can be chaotic in an environment. Okay, so it provide full control and visibility across your cloud native application platforms. Okay, so it includes CSPM, CWP, IEM, uh, etc. Okay, there are additional tools like CIEM that are getting popular now. There are API specific tool, API scanning specific tools. And what happens is each of these technologies like CWP, CSPM, they have different span of control or focus for their use cases. So CSPM typically works at infrastructure level. So it does an agentless, typical and agentless scan, understands your PaaS components, networking configuration, storage, compute, identity and permissions. So identity permission component is read by the CIEM module. And once it comes to workload and ISC templates, it is typically CWPP capabilities. Okay, now what is also happening right now is entire software supply chain, that capability is also getting developed in the industry as I am following various companies who are in this domain. So that is also getting integrated into the CNAPP platform, so that for an organization there is a single pane of glass to track everything. Now let's look into details of CSPM and CWPP. So CSPM and CWP are adjacent. CSPM looks into asset inventory, configuration, etc. It works at the configuration layer, right? The entire your cloud control plane essentially. And CWP works at the data plane layer. So it is more focused on the workloads and what's happening with the workload. Okay, so again, CSPM looks at your control plane configuration, and CWP looks at your workloads. Okay, so very clear in terms of their functionality. Going deeper into the CWP side, it provides controls around workloads of firewalling, system integrity, application whitelisting, exploit prevention, EDR, threat detection response, HIPS, malware detection, etc. Okay. Now there are various tools available in CWP. Not every tool will provide similar functionality, but these are the common things that the platform should have, as I mentioned. CIM specifically is very interesting. This is is a high growth area right now. It's evolving. So what it does, it looks into your infrastructure entitlements and understands how permissions are assigned to various components in the infrastructure. Okay, so it looks at entitlements on your resources. So example, things like file shares, databases, workloads. Looks into service entitlements, who can start, stop VMs, what permissions are set for compute, storage, and network permissions. It looks at management entitlements, so role-based asset control, security settings, and IS admin accounts. Okay, what it then does is it performs analytics. So it compares incoming or static data, is current configuration, with the incoming real-time log and event data or audit data. So current configuration with the user behavior data, and it can help you find out issues. So example, a user has a specific permission, but he never uses that permission. So it would tell you that this account has over permissive entitlements, and hence I recommend you to change it, and it will recommend you permissions that are needed for that user account. Okay. Now it can also do predictive analytics as well as prescriptive analysis. Now this is getting developed right now. It's as I'm tracking companies, they are focusing to build these capabilities. Okay. Now, so that was CIM. Now, what do we need to learn about CIM or CNAPP? Is essentially first learn how cloud native applications work. I'm assuming that you have a little understanding of this, because this is this is not a typical cybersecurity topic. Typically in cybersecurity, we deal on the security incidents and infrastructure security. But as applications are moving towards cloud native world, this is very important for us to understand how cloud native applications work. So which means you understand containers, Dockers, Kubernetes architectures, understand what native security controls are provided by these components, the native platforms. Also understand what third-party products provide on these platforms, and get certified if there is an option like that. Okay. With that, thank you so much. I'm very grateful to the companies who have provided content for today's podcast. Companies like Gartner, AWS, Medium Block, Cloud Native Computing Foundation, and many more. Thank you so much. It's very hard for me to mention all these names, but I'm very grateful for you to provide this content for learning. With that, thank you so much. I'll see you next time. Keep learning.